right, crew. This last 2 days we've been looking at subtraction on a number line. We've been reading subtraction as being takeaway. We've also been reading subtraction as the distance between two numbers. Today we are going to be, is there a reason you're not writing down the title? Today we're going to be looking at base 10 drawings. We did some work with base 10 drawings with addition. You're writing all of it. And the strategy my class actually last year named, and they wanted to call it the black hole strategy, which kind of makes sense to me. So we've got a title and a subtitle. Title is base 10 drawing subtraction, and our subtitle is black hole strategy. Go ahead and write that down, please. What do you know about black holes? It's hard to talk about black hole strategy if you don't know what a black hole is. Gia, what you know about black holes?
A black hole is like this, like a giant black hole that sucks mostly like a bunch of stuff in.
Okay. What you know about black hole, Carl?
Kind of like geo, but like, so it's like this big hole. So sometimes it can be really deep, and there can be like animals or spiders in there.
Let's think about where a black hole might be. Because that might make it a little more sense. Kaden, where might a black hole be? What? Black holes mean space, as in outer space.
Does that mean there's planets?
There can be planets in it, but not animals.
You're awesome.
Jalen, what you know about black holes?
That it decays all life that's in it.
Okay. John?
You see, a black hole, are in space, but they're actually far away from the solar system. That means they're in the galaxy, which is far away from the solar system.
Correct. Hello, what you know about black holes?
They're black.
They are black. Bryson, what do you know about black holes?
I know that they could be in Arizona.
No. Nope. Zach?
It's so deep you can't see the bottom.
Yeah.
It can be like never ending.
It can be never ending. Ariana?
It's just all black.
Sure. Black holes are going to be things that when something were to get sucked into it, there's no coming back. It's gone forever. It is a gravity-sucking vacuum, if you will. So anything that has gravity is slowly being pulled into that black hole. Now, as John said, it's not anywhere near Earth. It's not anywhere near any of our solar systems. There are black holes in outer space, but they're galaxies away. Now, you're probably wondering, what does this have to do with subtraction? So we know that subtraction can be thought about as takeaway. So go ahead and write this equation, please. John?
I think another black hole is a whirlpool, right?
No.
Because it's kind of like a whirlpool, because it sucks in stuff, right?
That's one similarity. So we've got 78, take away 12 is worth something. Underline the 78. That is our whole, or our total. And I'm using the word whole that starts with a W. Whole. I'm not using the same word there. It's a different whole. It's our total. So that could be the total amount of pencils I have, the total amount of puppies I have, the total amount of bananas I have. We're going to draw that using our base 10 pieces. How many hundreds flats am I going to draw?
0.
How many hundreds flats am I going to draw? Carl? 0. I don't have anything worth 100. How many tens rods am I going to draw? Gio?
70.
No, I'm not drawing 70 of them. How many tens rods am I going to draw? Gio? 7. Go ahead and draw your 7 tens rods. They are worth 70, but I'm only drawing 7 of them. How many ones bits? Knock it off. Am I going to draw? Quickly. 8. So far, so good. Split your page in half. Not all the way down, just draw a line next to where you draw on your pieces. And then we're going to draw our hole. This is our black hole. We are taking away what? What is coming out of that 78 and going into the black hole? Heidi? 12. The symbol means take away. I'm going to write a 12 above it. I'm going to do this next piece with red just so you can see it. Obviously, continue to use your pencil. I need to take things from here to build 12 on the inside. What do I need to take in order to build 12? Madison? All right. Madison wants me to take 2 ones. I'm going to cross out 2 ones, and then I'm going to put them in my black hole. Does that make sense what I did? What else do I need to take in order to make 12 in the black hole? It's not a trick question. Mackenzie? A 10. So I'm going to cross out a 10. And I'm going to put it in my black hole. Do I have 12 in my black hole now? Yes. Now all I have to do is count what's left. Count with me. Ready? 60. 66. So far, does this make sense? Yes. Are there any questions as to what's happening? So, let's try another one. We've got a new equation. This time we're writing 92 take away 36 is worth mystery number. We're writing the equation. John, it should not be giant. No, you can write it in math language just as it's written there. It should be on the line shut. It should not be gigantic. First thing we need to do is we need to build our total. What is our total for our whole? What is our total for our whole, Rylan?
Our total for our whole, so right now is 92.
92. Go ahead and build the number 92. Actually, I'm going to do this flat. our number 92, we need our black hole. What is going in our black hole? What is going in our black hole? Yeah.
36.
36. Above our black hole, we're going to write 36. What do I need to move into my black hole to make 36? Jalen? I need 3 tens. Cross out 3 tens. And then put them in our black hole. What else do I need? Okay, so what else do I need?
6 ones.
6 ones. How many ones do I got? Huh. That seems to be a problem. Right? I only have 2 ones, but I need 6 of them. Let's go ahead and knock out those 2. Alright, so now I've got 32, but I need 36. I know, you know, that if you had $92, you have enough money to pay for $36. So it's not that we can't do that. Maclo?
You can make a 10 and then break it up to 6.
Not to 6. Because if I go to the bank and I say, hey, break apart this 10 and they only give me 6, I'm going to be big mad. I'm going to break it into 10 ones. So, I'm going to take one of my 10s. I'm going to cross it out and I'm going to draw all 10 ones. Don't get lazy. Ones can be made into 10s. We know this. Sit up. However, sometimes we have to do some breaking to get back to our ones. Now do we have enough ones to move over to finish our 36? Yeah. How many more do we need to move over? Carl? 4. Cross out 4 more. And then I move them over. We're doing this right now? In your notebook? Good. All right, let's count what we've got left.
10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56.
56. Next blank page, title it Ungrouping, please. Put that off your head. It's about to be in your book bag. Alright, I want you to underline the prefix un. You've seen words with that same prefix. That prefix has a meaning. Does anyone know what un means? Someone? It means not. Un means not. When we're ungrouping in subtraction, we are taking something that's in a group and breaking it apart into smaller sections. We are taking something in a group, and when I say group, I mean like our ones have been turned into a 10. This is a group of ones, right? We are taking something in a group and breaking it into smaller but still equal pieces. This is what Mac and I were just talking about. He wanted to break that 10 into 6 ones because we needed 6 ones. But breaking a 10 into 6 ones is not equal. We have to make sure that when we're breaking up, we're still keeping an equal amount. So we know 110, here's my 110. If I were to break that up into equal smaller amounts, how much would that be? What would be an equal smaller amount that I would break that 110 into? Right there? Tyler? Yeah, how many ones? I need 10 ones. Here's my 110 is equal to 10 ones, or 10 bits. What if I had 100 flat? What would be something smaller that I would break that into? That would still be worth the same. Jack? I could break it into 10 tens, those 10 rods, worth the same amount. What else could I break it into? It would be pretty terrible, but you could do it. Colby? 100 ones. What about thousands cubed? What could I break that into? I could break it into 1,000 ones. That is equal, just annoying. But it is equal. What else can I break it into, Ariana? 100 tens? Anything else? Okay.
10 100s.
10 100s. Yes.
I'm noticing that the bigger number we get, the more you can use.
Say that one more time.
The bigger number we get, the more you can use.
What do you mean by the bigger number we get?
Like, for the tens, we only got 1.2 10 ones.
Yep.
But for the hundred, we got 10 and 10. And the 100 ones. And for the thousand, we got 1,000 ones. 100 tens and 100.
Oh, so let's look up on our chart up here. So Evelyn is saying that with my tens, the only thing I can really break it into, your eyeballs should be over here, is my ones. But with my hundreds, I can break it up into my tens and ones. And with my thousands, I can break it up into hundreds, tens, and ones. What do you think my millions? Can you recognize it? Okay, could I break it up all the way into ones? That works. What else could I break my millions into? You kidding me? I could break it into 100,000. What else could I break my millions into? Okay. 10,000. All of these make the next one. Right? I need ones to make tens. I need tens to make hundreds. I need hundreds to make thousands. I need thousands to make 10,000. It's like a set of building blocks. So far, so good? Alright, let's try another black hole strategy equation. $379 take away 182. Go ahead and start building 379 because you know we're going to need to start there. What's going in my black hole? Huxley? 182. What do I need to move over? What do I need to move over? I should see more hands in this. What do I need to move over? Keegan? A 100. Cross it out. Move it over. What else do I need to move over? Caleb? I need to move over 8 tens, right? Alright. 1, 2, 3, 4, 5, 6, 7. Ooh. I only have 7 of them. I'm going to go ahead and move them over because I do have those 7. But I need that 80. I have 10s in this number. They're just hiding. Where are they hiding? Imagine. They're hiding in 100. I'm going to break apart or ungroup this 100, Madison. And how many 10s am I going to get? 10. You got to draw all 10. Even though I don't need all 10, I would be big mad if I went to the bank and I said, here's my 100, and they gave me back 110. Would you be big mad? Yes. Yeah. So even though I only need a 10, I still need to get all of it set up. Traylon, do I now have that extra 10 that I need? Yep, go ahead and move it. Now what do I need to move? Again? 2 ones. Do I have enough ones right now to do that? Yeah. Now let's count what I got. Ready? 190. All I got left is 197. Write that equation down. Do you think someone could translate that into English for me? Read that as an English problem, one that I know all the words. Evelyn?
3,200. Yeah, 3,221. Take away 199. It's the same value as.
Beautiful. You need 3. Oops, I'm going to do it in black. Hang on. We need 3,000 cubes. Because we have 3,000. Oh, sorry. We need 3 space 1,000 cubes. Not 3,000 of them. Good call, Zach.
So that I've drawn it.
All right. What's going in my black hole? What is going in my black hole? Macklin? What am I taking away? I'm not even moving anything yet. What is and going to end up in my black hole? Oh. Huxley, what's going in my black hole? 199 is going there. But I'm not going to move all of that, right? Macklin, what do you want to move first? A 10? Well, I need way more than just a 10. I can move my 10s, but I need more than just one of them. I can move 100. Do I have 100 over here? Yes. Yeah. Cross it out. Move it over. What else am I going to do now? What else can I move? What else do I need to move? Mackenzie?
9 tens.
I need to move 9 tens. Okay. 1, 2. Oh, yeah. I only have 2 of them. Is that it? Is that all I can do?
You got me in one. You can break a 100 into 10 tens and then
Break up that 100 into 10 tens. Still the same value, just looks a little different, and now it looks like I can use some stuff. Alright, I already moved 2 over, so I'm going to finish. 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. John, what do I do next?
the one.
The ones. How many ones do I need to move?
9.
I need to move 9 of them. But John,
But
I only have 1.
you have to break up a 10.
How many am I going to get when I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now do I have enough in the right form
Yes.
to move them over? Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. let's count up what we got. Ready?
1,000, 2,000, 3,000, 3,100, 3,010,
3,010. I don't have any hundreds.
3,020, 3,021, 3,022.
3,000. I have no tens, so hundreds, so there's a zero there. What was the number? 2,022. 22? Does that make sense?
Yes.
Happy? So far, we have learned 3 subtraction strategies. We've learned to use a number line and just count backwards. That's probably the first strategy you ever learned anyway. We learned that I can make 2 endpoints and just figure out the distance in between. If you're looking at me, that's a really good way to show me you're listening to what I'm saying. And then the last one we just did, which is our black hole strategy, where I'm literally taking the pieces away. In a moment, we'll put you in partners. We got 3 problems to do. One is a naked number. It's just an equation. You just have to solve it. The other 2 are word problems. That means you need other things. What other things do you need when you're solving a word problem? What other things do you need in solving a word problem? You need a bar model. What else do you need? Evelyn? You need an equation. What else do you need, Caleb? You need an answer sentence. What else do you need? Carl? No. Heidi? You need an answer. You need an answer. We gotta solve it. So for naked number, you just gotta solve it. But those 2 word problems, I need 4 things. Answer sentence, model, equation, solution. That makes sense? Mm-hmm. If you need more space, where can you use? Back. Just turn over. Some of us write giant. I get it. Just use back. Any questions? Can you use your notebook? Yes, you can. Can you use your neighbor?
No. Yes.
Your partner? Yes, you can.
I can't remember, she said.